Introduction to Printed Circuit Board. What is PCB? Printed Circuit Board, PCB, or printed wire boards electrically interconnect all the components, mechanically support to the components, non-conductive substrate. It dissipates heat generated by the components. PCBs are rugged, inexpensive, and can be highly reliable. Printed circuit boards are called as printed wire boards. Printed circuit boards base for physically supporting and wiring the surface mounted and socketed components in most electronics. Why PCB boards are green? Green color indicates that it is made from glass epoxy, which is naturally green. PCB could be made in every single color that exists. The finishing color is usually a soldered mask. This mask is applied for safety reasons for preventing eventual short circuits. Advantages of PCB. There are many reasons for using PCB instead of other interconnection methods and component mounting techniques. The size of the component assembly is reduced. Quantity production is achieved at lowest unit cost. Circuit characteristics are maintained without introducing variation in inter-circuit capacitance. They ensure a high level of repeatability. Inspection time is reduced because printed circuitry eliminates the probability of error. Chance of miswiring and short-circuited wiring are minimized. Evaluation of printed circuit board. The first printed circuit board PCBs can be traced all the way back to the early 1900s and a patent for printed wire. It was in 1925 that Charles Dukas first submitted a patent that involved creating an electrical path directly on an insulated surface. It was a revolutionary idea because it could eliminate complex wiring and provide consistent results. Still, they did not really catch on until after World War II, when Dr. Paul Eisler in Austria began making the first real operational printed circuit boards in 1943. Before printed circuits became the common component used in electronics, point-to-point construction was used. This meant some extremely bulky and unreliable designs that required large sockets and regular replacement. Most of these issues were directly addressed when PCBs went into regular production. 1920s, the early PCB material could be almost anything, from bakelite and masonite to plain old thin pieces of wood. Holes could be drilled into the material and flat brass wire would be riveted onto it. It may not have been pretty, but the concept was there and it worked. It was often used in radios and gramophones at the time. 1947. First double-sided PCBs with plated through holes produced. 1950s to 1960s. The types of material used for the board were shifting to different resins and other materials, but they could still only be printed on single side. The wiring would be printed on one side and the electrical components would be on the other. Still, it was much more efficient option than bulky wiring, so it was starting to see a wider adoption. One of the biggest steps forward came in 1956 when the US Patent Office granted a patent to a small group of scientists representing the US Army for the process of assembling electrical circuits. At the time, the process involved drawing the wiring pattern and then photographing it onto a zinc plate. This plate could then be used to create a printing plate for an offset printing press. This is what was used to print the wire in acid-resistant ink on copper foil, which could then be etched by an acid solution. 1957, IPC, the Institute of Printed Circuits, formed and held first meeting in Chicago, IL. 1960s, multi-layer, 4-place layer count, PCBs, begin production. 1960s to 1970s. Boards were designed using 4:1 red and blue line vellum method for hand tapping components and tracks. A precision camera then produced the 1:1 negative manufacturing film. An experienced designer could lay out and tape a board at the rate of about 2 hours for each equivalent 14-pin IC on the board. 1970s. The circuitry and overall size of the boards were starting to get a lot smaller by the 70s, and a hot air soldering methods began to be used. This is also when the Japanese developers began to create screen processes that used various aqueous developed LPIs, liquid photo imageable masks. This became the industry standard over the years. 1980s. Surface mount parts became the preferred option over through-hole components, which led to further size reduction while maintaining the same level of functionality. 1986. RS-274X released as an enhancement to RS-274D data format. New version supports embedded aperture information, relieving the need for external aperture definition files. 1992. Valor Computerized Systems founded, introducing Genesis 2000 software for PCB, CAM and DFM. 1990s. While the complexity of modern circuit boards continues to go up, the size of boards and the cost of material has generally been able to go down. Once developers were able to start components of printed circuit board are base, which is a thin board of insulating material, rigid and flexible, which supports all conductors and components. The conductors, normally of high purity copper in the form of thin strips of appropriate shapes, firmly attached to the base material. Base. The base provides mechanical supports to copper areas and all components connected to the copper. The electrical properties of the completed circuit depends upon dielectric properties of the base material. The conductor, not only providing electrical connections between the components, it is also used to solder attachment points for the same. When the completed board provides mechanical supports to the electrical connections to the components, it is essentially known that printed circuit board or printed wiring board. PCB characteristics. Through-hole technology. The first PCBs are used through-hole technology, mounting electronic components by leads inserted through holes on one side of the board and soldered onto copper traces on the other side. Boards might be single-sided with unplated component side or more compact double-sided boards with components soldered on both sides. Horizontal installation is done by bending the leads 90 degrees in the same direction, inserting the part in the board, soldering the leads and trimming off the ends. Leads may be soldered manually or wave soldering machine. Through-hole manufacture adds to board cost by requiring many holes to be drilled accurately. Limits the available routing area for signal traces on layers immediately below the top layer on multi-layer boards, since the holes must pass through all layers to the opposite side. Once surface mounting came into use, small size SMD components were used where possible, with through-hole mounting 1/10 of the size and weight of through-hole components and passive components much cheaper. Price of semiconductor surface mount devices of components not suitable for surface mounting. A box of drill bits used for making holes in printed circuit boards. While tungsten carbide bits are very hard, they eventually wear out or break. Making holes is a considerable part of the cost of through-hole printed circuit board. Surface mount technology. Components are mechanically redesigned to have small metal tabs or end caps that could be soldered directly onto the PCB surface instead of wire leads to pass through holes. Components became much smaller. Component placement on both sides of the board became more common than with through-hole mounting. It allows much smaller PCB assemblies with much higher circuit densities. Surface mounting lends itself well to a high degree of automation, reducing labor cost and greatly increasing production rates. Components can be supplied mounted on carrier tapes. Surface mount components can be about 1/4 to SMDs are determined more by the chip itself than the package, with little price advantage over large packages. Challenges in modern PCB design and manufacture. Main stages in electronic product development are shown in figure. Concept. It defines specifications, requirements, and overall architecture of design. Capture defines design intent by describing its functionality. Layout. It determines placement of components and routing. Above steps leads to hardware prototype and manufactured item released into market. Not long ago, designers used pencil, pen, paper to design a circuit and layout. Nowadays, AutoCAD design were developed to make easy circuits. When subsystems are assembled together, it leads to complex in single board. Today's electronic system require to increasing fast, small, low power, lightweight components. Clock frequency and signal speeds are rising dynamically. It leads designer to design AutoCAD and EDA tools. Major markets drive for PCB industry. Complexity or performance, form factor or size, reliability or quality, time to market or cost.